Hello everyone, my name is George and this is Bobby.
Hi.
We are here to present you our presentation, which is titled General Application of Arithmetic and Geometric Progressions. Right now Bobby will continue with our first problem.
Yes, we have the first section, which is titled Application of Progressions in Physics, especially. So I will continue with our first task today, which is for a body which free falls. In the first second, it elapses 4.9 meters, and each second following more, 9.8. Our question is how many meters will it take for it to reach the ground in 1 minute? So we use A1 to denote 4.9 because this is the starting number of our arithmetic progressions, and D will be equal to 9.8 because this is the difference of our arithmetic progression. And by using the common formula, we have S60, which equals 2 multiplied by 4.9 plus 60 minus 1 multiplied by 9.8, all of this divided by 2 multiplied by 60 again, because 60 seconds have 1 minute. Then we, after making the necessary mathematical equations, we get the following result. S60 equals 2 multiplied by 4.9 plus 59 multiplied by 9.8 multiplied by 60, all of this divided by 2. After we divide, we get the following result. Sn equals 9.8 plus 59 multiplied again by 9.8 multiplied by 30, because we have divided, as I said, just by 2. Which the following result is 17,640 meters, which is approximately 17 kilometers. And this is my first problem. I have solved it, so our answer is 17 kilometers. Now Joro will continue.
Okay, I'll continue with our next problem, again in the area of physics. Our next problem is this. The period of radioactive decay of plutonium-239 is approximately 2 days and 8 hours. How much time will it take for 64 grams to turn into 1 gram of plutonium? As we know, 2 days is equal to 48 hours, and plus 8 hours is equal to 56 hours. An is equal to A1 multiplied by Q raised to the n minus 1. After we do the math, we know that n is equal to 6 periods. 52 multiplied by 6 is equal to 336 hours. These hours are equal to 14 days. With our next problem, we have a female insect. This problem is in the area of biology. A female insect lays 2000 eggs, after which it dies. From half of the eggs are hatched female specimens, which after a week lay 2000 eggs. From half of which are hatched female specimens, and so on. How much will it take the female insects of the 6th generation wait if all female specimens survive until they lay eggs and one of them weighs 1 gram? The solution is this. A1 is equal to 2000. Q is equal to 2000 divided by 2, which is equal to 1000. N is equal to 6. And after we do the math, we get 2 multiplied by 10 raised to the 12 tons. Okay, now I will show you our next problem, which is very interesting. At 50 degrees, the velocity of a chemical reaction is 0.1 mole per second. After a 10 degrees increase in temperature, the velocity has increased 4 times. Draw the graphics for 50 to 100 degrees. So we have T1, which is equal to 50 degrees, Vt1 is equal to 0.1, T2 is equal to 60 degrees, and Vt2 is equal to 0.1 multiplied by 4, which is equal to 0.4. We get 0.4 and we put it on our graphic right here. I can show you right here. Then we multiply 0.4 by 4 again, and we get 1.6. Then we put it right here, and so on. We multiply by 4 and we get the number and we put it on the graphic.
Our next problem will be something completely different, because we will not be specifying an area in which to use geometric and arithmetic progressions. So I will show you how we can use these progressions in our everyday life to solve simple problems. The problem is as follows. A bank has a president, 3 vice presidents, 6 head of management, and so on until the 6th level of clergy, which is a common clerk. How many employees does the bank have? That's our question. The solution is as follows. A1 equals 1 and Q equals 3. So we use the formula for the common member of a geometric progression. And we get the following. S6 equals 1 multiplied by 3 to the raised to the 6th minus 1 divided by 3 minus 1, because we have Q, which is 3 across. Then we get a half multiplied by 3 on the 6th minus 1, and this equals to 728, and we divide all this by 2, as I said, and we get 364. So our answer is 364 employees. Now shall we continue?
Our last problem for today is in the same area, and it is: Maria wanted to trace her family tree 5 generations back. For the first generation, she had a mother and a father. For the second, 2 fathers and 2 grandmothers, and so on. How many names should she write in her family tree? The solution is simple. A1 is equal to 2, Q is equal to 2, and the first generation we have 1 couple. The second generation we have a second couple. A1 is equal to 1 and Q is equal to 2. We are looking for S5. So S5 is equal to 2 multiplied by 2 raised on the 5th minus 1. All this divided by minus 1, 2 minus 1. After we do the math, we get 62 names.
So I will now present to you the theory of Thomas Malthus. You may have heard of it, you may have not. It doesn't matter. I will show you how practical use for geometric and arithmetic progressions can be rather life-changing. Thomas Malthus was an English economist, sociologist, and priest. He graduated from Oxford University in Jesus College, and he majored in theosophy. He published his first famous book in 1834, which is called An Essay on the Principle of Population. In it, he states that the population will lead humankind to disastrous catastrophe, because the population will grow in a geometric progression while our resources in arithmetic one. So this means we will not have enough resources to support ourselves. Basically, he suggests that there are a number of ways in which to restrain the growth of a population, such as sexual, sex, domestical wars, famine, diseases, you name it, it's all there, and they should be used to reduce the number of people that live on our planet. Well, in the 19th century, his theories became widely acknowledged, and many scholars used them to prove different problems, and he was somewhat famous, and the doctrine that follows his movement is called Malthusianism. That was all from us for today. I hope you liked our presentation. We have used problems from different sources, but I think it was rather good, so enjoy. Thank you.